Again, I'd like to introduce myself for those that have just joined. I'm the product manager for the Phocos group. If you have any questions also after the session to me, then you can feel free to contact me about this product or any other product that we have. Okay, so this is the content of today's session. I'll start off with a quick introduction of the devices themselves. We have two at the moment, one which is already released and one which will be released in about 1 or 2 months' time, so quite soon. Then we have 5 use case ideas, so 5 different ways that you can use this product for various scenarios that you might encounter with your customers. We have a list of special features, so those include some features which you may not find on other inverters of this type, or which are very specific to this device and that will just help you understand the AnyGrid a little bit better. Then we have the benefits of this compared to, for example, a traditional setup of having an inverter and a charge controller separate from each other on an off-grid system, or some other benefits as well. Then I'll look at the extensibility, because with these devices we can cater to anything from 3 kilowatts to about 45 kilowatts, because you can hook many of these together. Also, I'll focus on that in the extensibility section. And I would consider those first 5 sections up to extensibility as being relevant for salespeople, and generally for anybody who wants to get a rough overview of the device. And then the last 2 sections regarding system sizing, grounding, and surge protection, those will have to be a little bit more technical. I can't get around that. So let's get started with the introduction. We call this the AnyGrid Hybrid Inverter Charger. That's the full name of the device. And I'd like to take a moment to just explain to you what we mean by AnyGrid and why we've used this term for this family of devices. So I'm sure all of you are familiar with the terms on-grid and off-grid. Of course, on-grid refers to typically grid injection inverters, which are there to primarily produce PV power and to either use it directly in your home or to sell all or some of it to the grid. So this typically means that you need to open a contract with your grid operator to be able to sell that energy, and then in return, of course, to get money for the amount of energy that you inject into the grid. So anytime you're working, let's say, grid interactively, so this is parallel to the grid, that's when we consider that to be on-grid. So for off-grid, we can have really completely isolated systems which have no point at all where they touch with an existing public grid. So they could be in the middle of nowhere. They could be voluntarily off-grid by people that are just not willing to connect to the grid, or it might be too expensive to do so, etc. So off-grid can be anything from a small hut in the middle of nowhere to cottages to homes where it's just not economically feasible to connect them to the grid, or even just for people that are from an environmental perspective not willing to hook up to the mains, basically. So AnyGrid, we're using this term to combine the on-grid and off-grid, and also to have the various intermediate scenarios in between. So here I have a list of some of the different things that come to mind with AnyGrid. So one of them would be unreliable grids, for example. In many countries, we have load shedding, where there's either controlled or uncontrolled power outages, basically. Controlled in the sense that there might just not be enough power on the grid to go around for everyone. So different parts of a city or a town might have their power cut off temporarily to save power so that there's enough to go around. So this is something that you might know ahead of time. You may know that every day or maybe a day a week that for a certain number of hours you're going to face a grid blackout. So in that kind of a scenario, something like the AnyGrid will really help you out, because it's essentially an uninterruptible power supply with a whole bunch of other features you'll see later on. Then we can have a regular or sporadic blackout, so that sort of overlaps with the unreliable grids, although unreliable grid could also mean that you might have large swings in voltage or frequency where you just need to disconnect to protect your electronics, your loads from facing that. Then we have voluntary disconnection from the grid. So this is, again, for people that, depending on the country and the legislation, it may or may not be possible to basically run an uninterruptible power supply to power your loads. But in this case, to add some PV on top of that. So like that, you're basically using your PV energy when you can. And in that case, you can be completely isolated from the grid. So there's zero risk of injecting into the grid, for example, if you're not allowed to do so, or if you don't have a contract that you've signed with your power company. And you can still make use of that benefit of PV power to bring down your power bill. So that's what I refer to as voluntary disconnection, where the grid is existing and stable, but you're just disconnecting in order to use your own PV power. Then we might have different types of AC generators. So this could be, gensets of any kind, diesel, gasoline, could be a fuel cell, etc., where typically those energy sources are more expensive than PV, especially obviously once the investment has been made. So you want to have those as like a backup energy source, but you don't necessarily want to have them running all the time. Because as you probably know, having a diesel or a gasoline generator running all the time at a very small load, like maybe at 5 or 10%, it's like idling your car. You're basically just wasting fuel most of the time. So it's much more interesting to just activate the generator when you really need it, to then use that to charge your batteries, and then to switch it off again so that you're using it in a much more fuel-efficient way. Then we have taking advantage of changing power grid tariffs throughout the day. So depending, again, on your country or region, you might have different energy power tariffs for day and night. So power might be cheaper during the midday hours, for example, than the rest of the time. Some countries will do that to avoid excess energy in the grid and to put a premium on power when people use it most. So you can take advantage of those price differences. And then, of course, if you're allowed to, if it's legal in your region, you can also use this device to feed power into the grid to sell excess energy you may have. So let's get started with some of the basic specifications of the flagship device, which is the 5 kilowatt, 230 volt AC, 48 volt battery device. So you can see at the top here, we have the name. PSW stands for pure sine wave. H for hybrid, 5 kW for the kilowatt rating, the power output, 230 for the AC voltage, so that's your AC output voltage, and finally the 48V, that's your battery voltage. So you'll see in a moment that we also have a second model, and you'll see that there's some slight differences in that. So I'll start off with the first point, which is we have a 5 kilowatt nominal power rating. So you can use any types of loads. They can be resistive, inductive, etc. Up to 5 kilowatts. Of course, if you're using things like large motors or different types of loads which are not resistive, then you need to take into account your power factor. So typically what you do is, for example, let's say you have a 1 kilowatt inductive load with a power factor of 0.8. Well, then you simply divide 1,000 watts by 0.8, and that gives you 1,250 watts. So that's the rating you should be using. So you always divide by your power factor to get the correct inverter size for your loads. So here we can handle 5 kilowatts, and we have a surge rating up to 10 kilowatts. So it means that even if you have difficult loads which take a large surge to start up, you have several seconds time with twice the nominal power to get those units started up. We have a programmable 220 to 200 volt AC output. So you can select 220, 230, 240 as the output, and you can select 50 or 60 hertz as the output frequency. We can use all types of 48 volt lead-based batteries, so gel batteries, AGM, liquid electrolyte, tubular, whatever, and lithium iron phosphate. You could theoretically also use other lithium chemistries, as long as your nominal voltage and your minimum and maximum voltage are within the limits of the grid inverter. If you look at the manual, for example, you'll also see that we have things like equalization charge to give the best possible treatment to your lead batteries, so that's something you would typically not require for lithium. We have an 80 amp MPPT, which is integrated in the unit. with up to 450 volts tolerance of voltage from your PV side. So we have a very high maximum PV voltage for this type of inverter. We also have an 80 amp AC charger. So of course this 80 amp is battery side. So you can use the grid or any other AC energy source to charge your battery. Then we have various communication methods. You can see that on the bottom here, we have this rectangular display unit, and this includes both the display unit itself as well as the communication ports on the bottom. So this whole section is removable, and it's connected to the main inverter by just a standard Ethernet cable that you would find in pretty much almost every supermarket, but at least every hardware store or electronics market. So there's no special requirements for that cable. And you can use that to hook up the display in a different room, for example, to the inverter unit. So you might have a cottage, for example, where you go on vacation, and the inverter might be in a separate room connected to your batteries, and you want to see the battery level and all of the parameters from your living room, and like that, you can just pull a cable between the two. Otherwise, in the unit, in the display unit, we also have Bluetooth Low Energy, so BLE. You can hook up to that, you'll see later, with an app. So you also, like maybe if you're a little bit further away or you don't want to pull a cable, you can use the Bluetooth app as well. We have USB OTG as a method for you to upload battery parameters or to download the data logger, for example, because there's an integrated data logger. We have RS-485 communication, CAN bus, and RS-232, primarily for communication with lithium batteries, for example. And then we have a relay to start generator. When you have low battery voltage, for example, you can automatically start your generator. Then we have that integrated data logger for up to 60 days of data. We have a very short 10 millisecond switchover time between grid and off-grid modes. So this is almost standard for UPS. It's actually a good standard because if you look at most power supplies for computers, for example, they can handle up to 50 milliseconds typically. So we have a much shorter switchover time here between a grid mode and off-grid mode. Then we have an IP21 rating in terms of the environmental rating. So this is an indoor device. And it does have, you can see on the top here, and you'll see a more detailed picture later, it does have a washable dust filters on the left and right as well. So you can just wash those out, and conformal coating on the PCB assemblies. We have a galvanic isolation between the battery and the inverter unit. So this means you can ground the battery, positive or negative if you like, whichever way you desire. And then finally, we have the grid feed-in mode and the battery-free modes as special modes I'll explain later on. So next to this flagship device, we have a smaller brother or sister, which has 3 kilowatts as a power output rating. It's also a 230 volt AC device, and it's designed for operating with 24 volt batteries. So we have half the battery voltage and a little bit more than half of the AC output power. All of the other features you've just seen or heard of, and that I'll explain later on, are identical between these two models. I know that there's a lot of people which are signed on from the Americas. So a lot of you will have 120 volts as a grid voltage. So for you, you'll have to wait a couple more months towards, at SPI we'll present it, and towards the end of the year, we'll be bringing out 120 volt variants of these units as well for your markets. So here's a render of the bottom side of the unit, so you can see what kind of interfaces we have. So I'll start at the top. We have the remote display connector. So if you do remove this display unit, then you connect the Ethernet cable here and on the other side to the display unit if you want to put that in a different room than the inverter. Here we have our relay contacts, which are both normally closed and normally open depending on where you plug them in. So you can use any logic. We have the USB OTG port, if you want to download data from the device. We have a lithium battery port here, which is designed specifically for use with lithium batteries for communication. And then we have a serial communication port. So if you want to communicate with a computer, for example, or a Raspberry Pi or some kind of existing information system within your building, you can use this port to both query and program the inverter. Then on the bottom, we have all of the power connections and some more interfacing. We have the AC input on the top here and the AC output on the bottom. We have a resettable 40 amp AC fuse or input breaker here. So again, this is resettable. So if it pops out, you can just pop it back in. Then we have the parallel communication interface right here, because as you'll see later in the extensibility section, we can use that to interface with multiple units. So here we have the parallel communications, and here we have the battery connectors. They're on the inside, obviously, but the cable pass-through is here. So here's a real picture of the connections you can make. Again, you can see the AC output is here, and the AC input is here. We have the PV input right here and the battery plus and minus here. The terminals that are required here, the cable shoes that you crimp around, because we need big cables here. We're dealing with 100 to 200 amps of current on the battery side to be able to handle those 5 kilowatts or even 10 kilowatts for 5 seconds. So we basically include those terminals inside the packaging from the Inverter. Here you can see a picture of the display unit. So again, this is removable. On the left here, you can see a battery charging source selector for the timer. So you can set up a basic priority scheme. You'll see later what that means. And then you can override that with this button for a certain number of hours per day. Then we have various LED indications, so you can see if the device is currently running in grid or an off-grid mode. You can see if it's charging, and you can also see if there's an error, for example. And then on the right-hand side, we have the AC output source indicator and timer selector. So this is basically the equivalent to your battery charging selector. You can override your standard settings of the AC output source for a certain number of hours per day by using a timer. And then finally, here you have an AC output on-off switch. Now, this is not to be mistaken for a power switch for the whole device. This will really only control your AC output. So the advantage of that is if, for example, getting back to the cottage example, you might have a cottage which you only visit during the weekend and you're not there during the week. Well, then during the week, you would turn this off, and then the inverter will still, or basically the unit, the IndyGrid, will start up automatically when the sun is shining, so during the day, and it will charge your batteries. But it will never provide any current or voltage on your AC output, so you can be sure that none of your loads are running. But like that, you can always be sure that even if you're not home, your battery is always kept topped up. So here we have a more detailed picture of the dust filters. There's one on each side. Those are easily accessible from the side. So you can see here there's a single screw hole, and they're just clipped into the side right here. And the actual filter itself is rinsable in tap water. So you don't need to replace those when they do get dirty. So this is an overview of what a system could look like. You can see that virtually all of the components are optional. I'll get into more detail on what combinations make sense in the use case scenarios. But for now, this will give you an overview of what kind of devices or power sources you can connect to the IndyGrid units. So the one thing that is typically not optional is your AC loads. Obviously, if you don't have any loads, then there's not much use for having an inverter typically. So I didn't put optional on that one. Obviously, if your loads are turned off, the device doesn't really care much, but that's pretty much the point of an inverter, is to power your loads. Then we have the PV input, which is optional. We have the battery connection, so you can, but you don't have to connect a battery. So this is already a big difference between the IndyGrid and a lot of other devices out there. And then we have one AC input where you can connect either a public grid, or you could connect an AC generator of some kind, of fuel cell, etc. What's important to know here is that we have one AC input. So if you do want to use more than one AC source, you can, but you need to have an external source selector. So this could be a simple relay, for example, because you don't really need to care about phase shifts when switching over or being able to switch particularly quickly, because as soon as the AnyGrid detects that there's a problem with the frequency, or that even if it's for a very short time, the grid is failing, which is pretty much what will happen when you switch this over, then it will immediately switch to off-grid mode, and then it will resynchronize to your new AC source, and then it will detect that as a new valid source, and then it can use that. So basically, you do need an external switch, but it takes all of the guesswork out of quick switching and synchronization and all of those other issues. So now an explanation on all of these optional components. So you need to have at least one energy source, obviously. This device is there for converting from one energy source to the other and providing power where you need it to your AC loads. But you're going to have some kind of energy source, and obviously you can have more than one. So you're going to need to have at least one of these, being a solar PV connection, or a public grid, or some kind of an AC generator. Then, as mentioned, the battery is optional, so you don't necessarily need to have one. If you do connect a battery, then of course you use that as storage. The device can automatically act as an uninterruptible power supply, simply because it switches over so quickly between grid mode and off-grid mode. And in fact, when you're working between those two modes, when you're in off-grid mode, so for example, let's say your priority is to use as much PV energy as you can, so you want to voluntarily disconnect from the grid when you don't need it. Well, in that case, you will literally be disconnected from the grid. Both line and neutral will be disconnected from the grid, so there's no risk of backfeeding into the grid. And for this to work well, obviously with your existing loads, we need to have this very quick switch over time, so that you don't have any of your loads which would temporarily turn off during the switch over time. So that just doesn't happen. We haven't met any loads so far that will not handle that 10 millisecond switch over time. For those interested, that's 1/2 sine wave. And then as an option, with the connected battery, you can feed into the grid if you like. And without the battery, we say that a grid is required. Technically speaking, it's actually not. So even if you have no battery connected, you can still use PV to power your loads. But of course, because now we have absolutely no buffer in the system and we have no fallback energy source, if we don't have a grid connection, for example, then as soon as the PV power drops below the power of your loads, then of course the inverter can only turn off. So this is not recommended. That's why we write that a grid is required. But technically speaking, it would work without a battery, even, and without an AC source. So obviously the big advantage of working without a battery is that you can save that cost of investing into a battery. Or, for example, you could start off without a battery and you might say, okay, PV has gotten relatively cheap as compared to maybe 20 years ago, but batteries are still quite expensive. So you can start off with the AnyGrid, you can hook it up to your existing home, and then you can just add a battery later as they get cheaper. And then finally, if you're working without a battery, you can still obviously take advantage of your PV power. And if you do have any excess energy, so if you're producing more power from PV than you require for your AC loads, then it's up to you if you want to inject that into the grid or not. So there's a specific setting for that. If you're not allowed to inject into the grid, for example, then you would just leave that disabled. So now I'll move to the 5 use case idea. So use case number 1. This is an off-grid use case, so you can see that there's no grid connected here. We do require a battery in this case, and you're going to need either PV as an energy source or an AC generator like a genset, for example. You can start that automatically by the relay described earlier. So the benefits of this kind of system is that you have a vastly simplified system as compared to your traditional inverter plus charge controller plus potentially charger from the grid. So you're combining at least 3 devices into one, and that's not to speak of the whole synchronization and fast switching, etc. So you're really simplifying that down into a single device. Also, you have no requirement to coordinate communication between multiple devices because there's no need to have a separate charge controller or a separate inverter anymore. So the only multiple devices you might have is maybe more than one AnyGrid. And in that case, the communication is baked into the devices, of course, so they can handle that between each other. So there's nothing you need to do in terms of protocols, in terms of baud rates or fabricating cables, etc. So use case number 2 is a grid-connected scenario, so an on-grid scenario with battery and PV. So you would do this, for example, if you want to prioritize solar for electricity cost savings, so to save money on your power bill. Or you could even do the opposite. If you say that the most important, the highest priority for you is to keep your battery charged at all times for the case when the grid fails, then you want to have the opposite. Then you want to prioritize the grid. You want to use the grid whenever possible, and you want to use all of the energy to just keep your battery topped up. That is theoretically also possible. And of course, you can have various scenarios in between the two. If it's legal in your area, you can feed in as well in this scenario. But it's physically impossible to activate this function by accident. You'll see later how it's activated. So the benefits here are you can save electricity costs by simply prioritizing PV and just disconnecting from the grid when you don't need it. And then again, if it's legal, you can sell any excess energy you might have to the power grid if you have the contracts for that. Then use case number 3, again on grid. This time we have a battery, but we have no PV. So even in cases where you don't have access maybe to the roof because you might be in a multi-story building which is not your own, you have an apartment of some sort, etc., you could still use the AnyGrid basically as just a large uninterruptible power supply. The way you would have in front of just a computer, well, you see this as a large one which will act as a UPS for your entire home. So in this case, you benefit from the fast switching between the grid and off-grid modes. And you can be sure that your home is still running even if the grid fails. Obviously, in this scenario, because you have the public grid as your only energy source, the system is only as good as your battery. So obviously, when the battery capacity is depleted, then at some point the inverter will have to turn off. But it's definitely good to keep you running for probably several hours, even if the grid does fail.
For more videos and information, go to www.phocos.com. Phocos, making reliable energy access possible. Anywhere, anytime, any grid.